Hey everyone, my name is Gleb and I'm an IT student at Ukrainian Catholic University, as well as I have a great pleasure to be a curriculum specialist for Neuro AI course at Neuromatch Academy. And for this tutorial on double descent, I would like to lead you through all of the sections and discuss the results together. In the first section, we propose you to think about classical picture in machine learning, so-called bias variance trade-off. Indeed, with the increase of model's complexity, we can see the training error decreases, but at some point, test error starts to increase. We say that model becomes too biased towards training data and it has high bias. It performs poorly with generalization on unseen data. In general, we aim to find so-called sweet spot when the test error is the smallest enough. It usually happens in the middle of the model's complexity. So we propose you to play with this toy example on sinusoidal data. When we have 10 training points and 100 of test ones, we will have the network consisting of one hidden layer. We are going to fix weights from input layer to hidden one, W1, as well as bias. So those are going to be frozen during training. And we are going to change only projection from hidden layer to output one, W2. We are going to find it as minimizing mean squared error between true and predicted values. Of course, one can do that with gradient descent, but we can derive actually closed form analytical solution as we have only one unknown W2. So your task is to complete initialization of all of the weights W1, B, and W2, as well as forward propagation through the network. And after that, you are asked to complete generation of different examples for different number of hidden units in hidden layer. So see you in the next section.